In this problem, we have a 56 kilogram ice skater traveling at 4 meters per second to the north, who suddenly grabs the hand of a 65 kilogram ice skater traveling at 12 meters per second to the south. The two skaters continue skating together with joined hands. We want to find first, or describe first, what kind of collision this is. Second, we want to figure out what is the final velocity of the two skaters. And third, we want to figure out what is the decrease in kinetic energy during that collision. Let's start with the very first part, the type of collision that it is. Because the two skaters joined hands, we know that this is a perfectly inelastic collision. So again, because they joined hands, that's the main idea. The second part here, we want to find out what is the final velocity of the two skaters. And to solve this, we're going to use our conservation of momentum. Because no matter what type of collision takes place, momentum is always conserved. So the first thing we're going to do is we're going to draw a picture of what's going on. We have our two skaters. The first skater traveling north and the second skater traveling south. And we know the mass of the first skater is 56 kilograms. And the velocity of the first skater is 4 meters per second. Now that person is moving to the north, so that means that their velocity is positive. The second skater's mass is 65 kilograms, and their velocity is 12 meters per second to the south. Because that skater is moving to the south, their velocity will be negative. Now after the collision, they're going to join hands and skate off. And what I want you to do is think about what direction do you think they'll be traveling after they join hands? Do they think they'll be traveling north, the same as the first skater, or do you think they'll be traveling south, the same as the second skater? Now after they join hands, their masses combine. So we take our 56 and 65, and that makes a total of 121 kilograms. We want to find the velocity of the two skaters after they join hands and they're together. So I'll put a T for together, their mass together, their velocity together as well. We're going to use our conservation momentum, which states that the momentum in the beginning, and there's two objects with momentum in the beginning, skater 1 and skater 2, is going to equal the momentum at the end. And at the end, because they join hand, there's only one object, since they are together. We make our substitutions. Instead of M1, we have 56. Instead of V1, we have 4. Instead of M2, we have 65. Instead of V2, we have negative 12. Instead of MT together, we have 121, and we're going to find that velocity when they're together. Now we solve 56 times 4, and that comes out to be 224. This is going to be a plus negative, or minus, 65 times 12, which is 780. That is equal to our 121 times our unknown. We solve here 224 minus 780 is negative 556. And that is equal to our 121 times V. And now we solve for our v by dividing by the 121. We get our velocity. Comes out to be a negative 4.60 in units of velocity or meter per second. Now the reason it is negative is because apparently the skaters, after they join hands, are moving south. And the reason is because this second skater has more mass and more speed, and therefore has more momentum, and they'll kind of sway the total momentum towards that direction. Now in part C, what we need to do is we need to find what is the decrease in kinetic energy during the collision. So what we're going to do is we're going to find what is the kinetic energy to start, and what is the kinetic energy at the end, and then we're going to figure out what is that decrease in kinetic energy. So we have just figured out that this velocity is negative 4.6 meters per second. So let's start here by calculating what is the kinetic energy in the very beginning. Now there's two objects in the beginning. Kinetic energy, our formula, is 1/2 mv squared. But again, there's two objects, so we're going to have two of those. So to solve for that kinetic energy to start, I'll label this as my initial kinetic energy. I have 1/2 times 56 times 4 squared plus 1/2 times 65. Now this here in this kinetic energy is actually a speed. It's not a velocity. So the speed of the second skater is simply 12. Now if by accident I put in the negative 12, it's not going to make a difference because since it's squared, it's going to become a positive anyway. So if you put the negative or don't put the negative, you'll get the same answer. But technically, because this is a speed, we don't put the negatives in for speed because speed has no direction. We get this to be 448 plus 4,680, which gives us an initial kinetic energy of 5,128 joules. Now we solve for the final kinetic energy. Now there's only one object here, so there's only 1/2 mv squared. If there are two objects, then we write two of them just like we did before. There's only one. Our mass is 121. Our speed is 4.60. Again, I know it's a negative, but the negative is not necessary since it is a speed. We get the final kinetic energy to be 1,280 joules. Now remember, the kinetic energy goes down because it's an inelastic collision, so therefore we lose kinetic energy. Because it is perfectly inelastic, we have lost the most amount of kinetic energy as possible. Now we want to find out how much has that kinetic energy gone down. So we're going to take our 1280 and subtract the 5,128. We get an answer of negative 3,848. and the units of energy are joules. The reason it is negative is because the kinetic energy has decreased. The kinetic energy has gone down by that much. So that is the most amount of kinetic energy that could have been lost in any kind of collision between these two objects with those initial conditions.